In this learning module, we will cover some preliminary information about variables and data. Statistics is a set of procedures for describing, synthesizing, analyzing, and interpreting quantitative data. One can calculate statistics by hand or can use the assistance of statistical programs. Although there are highly sophisticated statistical software packages, the most common statistics can be calculated with Excel and/or through free online calculators. Before we discuss some specific types of statistics, let's talk a bit more about variables. As you might recall, variables are the things that researchers investigate. They are the measurable versions of concepts like intelligence, achievement, and self-esteem. There are 4 types of variables. The first are nominal variables. These are categories and thus are often called categorical variables. Nominal or categorical variables have no inherent number and can't really be measured per se. They can just be described. For example, gender is a nominal variable, as is ethnicity. If we were to give each ethnicity a numeric code in a data set, the numbers would just stand for what ethnicity a person is. The numbers wouldn't have inherent meaning. Similarly, the type of school, pass or fail status, and other nominal variables can be coded with a number, but the number doesn't mean anything other than what category the participant falls into. The next type is ordinal variables, which represent rank-ordered data. For example, class rank, or the place that one finishes in a race, first, second, third, etc., are ordinal variables. With ordinal variables, the numbers assigned to each person have some meaning, as 1 is greater than 2, which is greater than 3, etc. However, ordinal variables are somewhat limited, as the space between each person's rank might be very different. For example, the difference between the top 2 students in a class, ranked 1 and 2, might be a matter of a few hundredths percentage points. In contrast, the difference between students ranked 5 and 6 might be much larger. Even though the difference between the rank numbers 1 and 2 and 5 and 6 is the same, the actual distance in status or standing or performance between each student in the first pair is quite smaller than that of the second pair. Interval variables yield numbers that are meaningful in the sense that equal distances between the numbers or scores represent at least theoretically equal differences in the construct that is being measured. For example, on an IQ scale, the difference between an IQ of 100 and an IQ of 110 is theoretically the same as the difference between an IQ of 60 and an IQ of 70. Similarly, if a questionnaire has 10 items about the same topic that all use a Likert scale, where 1 equals strongly disagree and 5 equals strongly agree, we could add up the person's responses to each item for a total score on that questionnaire. The difference between a score of 10 and a score of 20 would theoretically be the same as the difference between a score of 40 and a score of 50. However, note that these variables do not have a true 0 point, representing the complete absence of the construct. Thus, we couldn't say that a score of 50 on the questionnaire represents twice as much agreement as a score of 25, or that an IQ of 100 represents twice as much intelligence as an IQ of 50. One additional thing to note. Some researchers treat virtually all psychosocial variables as ordinal variables rather than interval variables, given the difficulty of measuring psychosocial constructs accurately. However, for our purposes, we will treat variables like these as interval. The final type is ratio variables, which add a true 0 point to an interval scale. For example, a test score, 0 to 100%, is a ratio variable because the degree of difference between scores is equal, and a person can score 0, meaning that he or she did not answer any questions correctly. In this type of scale, not only is the difference between 10% and 20% the same as the difference between 50% and 60%, or 80% and 90%, but a score of 100% represents twice as many questions answered correctly as a score of 50%, and so on. The same can be said of scores that represent the actual number of items answered correctly, for example, 0 to 20 on a 20-question test, and physical measures such as time, height, weight, distance, and so on. The advantage of ratio variables is that all mathematical operations, addition, subtraction, multiplication, and division, can be performed on these data, whereas only addition and subtraction can be performed with interval data. Luckily for us, however, most statistical operations can be performed on interval and ratio data, so the vast majority of psychosocial variables can be analyzed statistically. In preparing quantitative data for statistical analysis, there are 3 steps. First, you must score the test, add up the number of behaviors observed in an observational protocol, or perform other preliminary data checking. If you have any nominal variables, such as gender or race, you might want to code those variables numerically so that each participant has numbers that represent his or her gender and ethnicity. Next, you should check your scoring for consistency and accuracy. If you have a very large data set, it is acceptable to double-check just 10 to 25% of the data set, but you should always eyeball the entire data set to make sure that there are no unusual values. For example, if the maximum score on a test is 100, you should not see any values above 100 for this variable. The third step involves tabulating data or organizing the data systematically, such as organizing the data by participant. For example, if you have more than one measure, you might want to group the measures by participant, rather than putting all the scores on the first measure together and all the scores on the second measure together. This will facilitate entering data into a spreadsheet, as spreadsheets are generally organized with participants as the rows and variables, or even items within a measure, as the columns. Here is an example of a data set with a few rows of a spreadsheet. In this data set, ID represents the participant number. COND represents the experimental condition. In this case, 1 means control group and 2 means treatment group. For gender, female is coded 1 and male is coded 2. Finally, ACH and MOT are the participants' achievement and motivation scores, respectively. Additional rows would be added for additional participants, just as additional columns could be added for additional variables. Now you are ready to analyze the data.